Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more about the wonderful world of respiration with the Batty Boffin. Hopefully you know by now that respiration is the conversion of glucose into energy by breaking down that big molecule, there it is, glucose, quite a big molecule, into smaller bits. Now we've looked at different ways it can be broken down. With aerobic respiration, which is the one we normally use, aerobic means with air, so it's the normal kind of breathing one. Normally we do glucose plus a bit of oxygen, releasing the energy, and we break it down into water and carbon dioxide that we breathe out. Now, another way of using it is not aerobic respiration, but anaerobic respiration. And we looked at that in an earlier video, so if you want to know about that, go check that out. In this one, glucose is converted straight into lactic acid. You can see it's just half of it, which releases energy, but you can't breathe out lactic acid. So we built up that oxygen debt and we had to pay that back later by converting the lactic acid into water and carbon dioxide and breathing it out. Okay, well that's fair enough. That's how we mainly break down glucose. But not everybody does it in the same way, particularly a very useful little organism called yeast. Now yeast, like all living things, still respires. It still breaks down glucose and turns it into energy, but it breaks it down in a different way. Now, at the bottom down here, I've added a new chemical to my list, ethanol. Ethanol, those of you familiar with the naming system, if you don't know about naming these chemicals, by the way, check out some other of the videos on how to name meth, eth, prop, bute and all that lot there. But ethanol is one of the alcohols. There's a whole load of them, and this one has the formula C2H5OH. I know I could have stuck that H in there and made it an H6, but it's usually written like that on there. And ethanol is the alcohol that we think of when you think of, like, you know, beer and wine and that kind of thing. Ethanol is the one that makes humans drunk. By the way, don't ever, ever try to drink any other of the ols. There's another one called methanol, okay, closely related to ethanol. Ethanol will make you drunk, methanol will kill you. So just don't even think about it. But ethanol's the one you find. Vodka is fairly well refined ethanol on there. So ethanol, that's one of the alcohols. And if you have a look on here, it's actually not far off from this one, is it? So you've got 6 H's, you've got 6 H's. There you've got 3 O's, there you've only got 1, and the C's. But you know, it's not far off. So you can imagine that if you chopped a glucose in half, you could make a couple of ethanols and a few other bits and bobs as well. So this is what you're going to do now. In the word equation, we're going to start off with glucose. And we don't need any air in this one, so there's no added oxygen, it's just glucose. And that's going to turn into some other bits. So you start off with glucose and you're going to chop it into bits. One of the bits is going to be ethanol, and the other bits could be oxygen, could be carbon dioxide, could be water. Not going to be lactic acid because that's too big, we're not doing that one there. So I'd like you to have a play around. See what you can make. Okay, so you've got to have at least an ethanol, we'll put that one in. Okay, so we'll have an ethanol. And remember that whatever you put in at the top, you've got to come out with the same things at the bottom. So if you put in 6 carbons at the top, you've got to come out with 6 carbons at the end. They could be in the ethanols, they could be in carbon dioxides. If you start off with 12 H's at the top, you've got to come out with 12 H's at the bottom. Well, there's 6 in that already, so that's quite a long way there. 6 oxygens at the top, you've got to come out with 6 oxygens at the bottom. Okay, that's only got 1, so obviously we need to have a bit more oxygen in somewhere, which could be here, or it could be here, or it could be here. So I'll leave that up to you. See if you can work out what we could come out with. Right, here we go, doing it with the formulas. There's my glucose at the top, and there's my ethanol underneath it. So just having a look at balancing, I'm going to start off with the hydrogens actually because they're so nearly right. 12 hydrogens there, 6 hydrogens there. Also, that's got 6 carbons and that's got 2, so I'm feeling like I want to double that 2 there. 2 ethanols. Just going to move that L up a little bit there. So if I have 2 molecules of ethanol, that's kind of using up quite a lot. I've already coped with the hydrogens, so that's great. A few more carbons and oxygens spare. Ooh, carbons and oxygens. I'm feeling some carbon dioxide coming out of this here. So how many of these are we going to need? Well, hydrogens are already dealt with, 12 there and 12 here. Carbons, I've got 6 at the top. Here, my ethanol uses 2 and I've got 2 molecules, so I've dealt with 4 carbon atoms there. I need 6, I need 2 more dealing with. So I think, how about if I double that? So that's now using up 2 carbons, that's using up 4, so that's my 6 altogether. Do the oxygens work? I've got 6 oxygen atoms coming in. Here, 2 molecules of ethanol, each having 1 oxygen in it, so that's using 2 oxygens. Here, 2 molecules of carbon dioxide, each using 2. 2 times 2, 4, 5, 6. Brilliant, we've done it. We've balanced the equation. 6 carbons, that's 4 and another 2, 6 carbons. 12 hydrogens, 5, 6, doubled, that's 12 hydrogens. And 6 oxygens, 1 oxygen doubled, that's 2 oxygens. And 2 oxygens doubled, that's 4, plus those 2. Yep, everything balances. So what we've got there is we find that we can break down glucose into 2 molecules of ethanol and 2 molecules of carbon dioxide. Now you say, oh, that's lovely, Batty, but why are you bothering telling me this? Because this is a very, very handy equation. Yeast does this. This is how yeast metabolizes glucose and turns it into, oh, by the way, it's giving out of energy in this point because we're breaking up the bonds, so we're giving out energy. Yeast, it can be used to generate ethanol, alcohol. That's how beer is made. That's how wine is made. All of the alcoholic drinks use this equation. Now, they don't all taste the same because the glucose comes from different places. If you get your glucose from grapes and grape juice, you develop wine. If you get it from hops and barley and grains, you get different types of beers and lagers and things like that. You can get it by fermenting rice, you can get it by fermenting potatoes. Anything that's got a starch, which can be converted into glucose, you shove your yeast in, your yeast produces ethanol, and that's the alcohol that people drink. Carbon dioxide is given off as a waste product. Sometimes you keep that carbon dioxide in, and that makes things like sparkling wines and champagnes, or it makes that frothy head on beer. That's the carbon dioxide that's given off as a waste product by the yeast. The ethanol is also a waste product. So when you're drinking beer or wine, bear this in mind. You're drinking yeast wee. Yummy. We also use this equation another way as well. Sometimes it's the carbon dioxide that we want, and we use this when we're doing things like baking bread. You put yeast in that and allow it to ferment, and what you're using there is you're capturing the carbon dioxide in the dough of the bread. It is actually also producing ethanol as a waste product, but don't worry, eating bread's not going to make you drunk. There's very, very little of it in there. It's the carbon dioxide that we're after for those. So that is one of the very useful ways of metabolizing glucose by using yeast. Yeast that changes glucose into ethanol and carbon dioxide as its 2 waste products. So, I'll see you next time, Batty fans.